So if we complete the square, we usually run into a situation, and I'm going to pick one of the homework problems, and then I'll come back and show you where it comes from. So let's just do problem number 14 out of the textbook. So if we do problem number 14 out of the textbook, we're asked to solve for x squared plus 5x minus 9 equals 0. All right? Now, what we're going to do is we're going to add 9 to both sides, and we get x squared plus 5 is equal to positive 9. Now, what is, oh, this has got an x in it, right? 5x, right? Okay. So now what Mr. Adams said, the next step, once we get it to look like this, I'm going to take whatever this number is, and I'm going to divide it by 2 and square it. Okay? So I'm going to say x squared plus 5x is equal to 9. And then what I'm going to do is I'm going to take plus 5 over 2 and square it on both sides. Right? That's what makes it legal. Whatever you do on one side, you have to do on the other. Now the question is, why do you do that, Mr. Adams? Here is the answer. I'm going to just put your brain on pause. We'll come back to this step in a second. If I take the reason we do that is because it's technically x plus 5 squared will give you this stuff right here. How do I know that? It's rigged. So if I put an x here and 5 over 2 here, and an x here and 5 over 2 here, and then I multiply it out, I get x squared, I get plus 5 halves x here, positive, just multiplying the row by the columns, 5 halves x here, and then what's 5 halves times 5 halves? Five halves squared, right? Now what I'm really doing is I'm multiplying it, right, because this is squared, I'm multiplying it by itself. And so then my answer is x squared plus 5 halves x plus 5 halves x plus 5 halves squared. Okay? Well, when you have 5 halves plus 5 halves, what do you end up with? 10 halves. What's 10 halves? 5. So what I've done is I have created a perfect square. By taking that middle number and dividing it by 2 and then squaring it, I've created a perfect square. So what I've done is I'm able to go from this step and say x squared plus 5 over 2 squared equals 9 plus 25 over 4. Because this line right here is the same as all this stuff here. So every time we're going to take that middle number, we're going to divide it by 2 and square it. And what that does is it rigs it up so we can take a perfect square. So now let's finish this problem, now that we're running out of space. How do I add 9 to 25/4? So I've got x squared plus 5 over 2, all that stuff squared, and it's not x squared, it's x. Oops. And so this is x, right? So it's x plus 5 over 2 squared. And I suppose I could write this as 36 over 4, isn't that the same as 9? Yes, Mr. Adams. So this is where we're at. Well, that would be x plus 5 over 2 squared is equal to, what's 25 plus 36? What's that? 61 over 4? Is that right? Well, I sure hope we get the right answer. I didn't make any mistakes. So now what we're going to do is we're going to take the square root of both sides. So over here I'm going to get x plus 5 over 2 is equal to plus or minus the square root of 61 over 4. What problem was that? 14? Alright, so now what I'm going to do is I'm going to say x plus 5 over 2 equals the square root of 61 over the square root of 4, or x plus 5 over 2 equals the square root, negative square root of 61 over the square root of 4. Now remember, that's a property of square roots, right? I could do that, right? Yeah? So now I'm going to subtract 5 from both sides. So I get x is equal to the square root of 61. What's the square root of 4? 2 minus 5 over 2. Or x is equal to negative square root of 61 over 2 minus 5 over 2. You guys with me so far, or is this where it starts to look confusing? Okay. So what can I do? Can I clean that up a little bit? Could I write it like this? X equals the square root of 61 minus 5 all over 2. Or x equals minus the square root of 61 minus 5 all over 2. Can I leave it like that? Yeah. Any questions?